Okay, let's go ahead and look at scientific notation. So I am back on the chapter 2 notes, and this is slide 12. It's at the bottom of page 6. Okay, so scientific notation is a product of a number between 1 and 10 and a power of 10. It's used in science because typically our numbers are very, very small or very, very large. So for example, to write 125 in scientific notation, so to write 125 in scientific notation, you're going to want to hop the decimal point so that there's only one number in front of the decimal. In this case, 125, there's no decimal given in this number. So if there's not a decimal shown, we know that it's right behind the last number. Okay. So in this case, we're going to have to hop this comma or the decimal point 2 spots to the left to get 1.25, so that we only have one number before the decimal point. Then we're going to write times 10 to the second power. How did I get the second power? Okay, well, let me show you. Each hop is equivalent to times 10. So since we hopped it twice, we need 2 10s. Okay, so let's double check ourselves and make sure that we have that the scientific notation is equivalent to this original number. Okay, if you write 1.25 times 10 to the second power, that is the same as writing it times 10 times 10. Okay, 10 times 10 is the same as times 100. So 1.25 times 100 equals 125. Okay, so our numbers are the same. This part of the number, whatever comes before the multiplication sign, that's called the coefficient. Okay, so you want the coefficient to be between 1 and 10. Between 1 and 10. So in this case, it's 1.25. Okay, and this part right here, that is called your exponent. All right, let's look at another example. Let's do 1700. To write this in scientific notation, you're going to have to hop your comma 1, 2, 3 spots to the left. So it will become 1.7. And since we hopped it 3 times to the left, our exponent will be positive. Okay. Write this number out again and check that your numbers are equivalent to make sure that you did it correctly. So just to sum up, if you hop your comma to the left to write a number in scientific notation, your exponent will be positive. So if you hop comma left to write a number in scientific notation, the exponent is positive. Okay. Now let's look at writing a number in scientific notation that's less than 1. For example, let's look at 0.0034. In this case, the decimal is shown, and in order to write this in scientific notation, we need to hop the comma once, twice, 3 times, so that we end up with 3.4. times 10 to the power of something. Okay, we want one non-zero digit in front of the decimal point. Okay, this coefficient needs to be between 1 and 10. Currently it's 3.4, so we're good. Times 10 to the power of. Okay, now let's figure out this exponent. In this case, we hopped our comma to the right 3 times. If we hop our comma to the right to get into scientific notation, our exponent is going to be negative. So if you hop comma to the right to get into scientific notation, the exponent, sorry, it got really blurry. The exponent is negative. Okay, go ahead and copy that down. Let's do another quick example. Let's look at 0.016. In this case, you have to hop the comma once, twice to the right, so that you end up with 1.6 times 10 to the negative second power. Okay. Now let's double check that this number written out equals our original number. Okay. 1.6 times 10 to the negative second power. If we want to get out of scientific notation back into normal notation, and the exponent is negative, you're going to hop it to the left. 1, 2, 0.001, oops, 1, 2, sorry, my mistake, 0.016, 1, 2 hops. So there we go, 0.016. They're the same. Okay. In summary, I want you guys to write this down. Okay. To represent a number that is greater than 1. So to represent a number that is greater than 1 in scientific notation, the exponent will be positive. Positive. Okay? Positive. So make sure you write that down. And also to represent a number that is less than 1, so a decimal in scientific notation, the exponent will be negative. Negative. Okay. Let's go ahead and look back at that example page. Here we go. So, under scientific notation, it says, number 1, express each number in scientific notation. So this is 4.5 million or 4,500,000. Okay, this number, we can't see a decimal point in it, but we know that the decimal is implied right there at the end of the number. Okay, now this number is much greater than 1. So since the number is greater than 1, if we are going to write this in scientific notation, the exponent will be positive. Okay, let's see how many times we need to hop this decimal point. 1, 2, 3, 4, 5, 6. Okay, 6 hops. So 4.5 times 10 to the power of 6. All right. Now let's look at B. Okay, the number is 0.0054. This number is less than 1. Therefore, our exponent is going to be negative when we write this number in scientific notation. We need to hop the comma once, twice, 3 times to get 5.4. Okay, so since we had to hop it 3 times, we put the 3 for the exponent, but it'll be negative 3 since our original number was less than 1. Okay, let's look at number 2. Here it asks, express each quantity in regular notation along with its appropriate unit. Oops, you guys can forget about this part. I left the units out. So just express each quantity in a regular notation. Okay, so A is 3.60 times 10 to the 5th. Okay, if we want to go from scientific notation into regular notation and the exponent is positive, we're going to hop to the right. Okay, that makes sense also because our positive exponent means that the number has to be bigger than 1. If we were to hop the comma to the left, we'd be getting a very, very, very small decimal, which is less than 1. So you guys always double check yourself. Okay, so here 3.60 times 10 to the 5th. So we're going to hop this decimal point 1, 2, 3, 4, 5 times to the right. Okay, wherever there are little spaces, we're going to fill in zeros. Our decimal point is right there at the end. Okay, so our answer is 360,000. Okay, let's look at B. 5.4 times 10 to the negative 5th. First of all, this negative exponent means that the number, when it is not written in scientific notation, so in other words, when it's written in regular notation, this number is less than 1. In order to get this number to be less than 1, we're going to have to hop the comma to the left, okay, so that it looks like a decimal. So I'm just going to do that so that there's more space for you guys to see. All right, so the number is 5.4 times 10 to the negative 5th. Okay. All right, 5.4, I'm going to hop the comma 1, 2, 3, 4, 5 times to the left. Okay. I'm going to fill in zeros everywhere. So if I write this number out in regular notation, it'll be 0.000054. Okay, this number is less than 1. This exponent is negative. Okay, so that makes sense. Let's look at C. All right, this exponent, again, is positive. So we're going to be hopping our comma to the right to ensure that this number, when written in regular notation, is bigger than 1. So here we're going to hop our comma or our decimal point 1, 2, 3 times, and we're going to end up with 5,060. Okay. All right, let's look back at our chapter 2 notes on page 7. Okay. Page 7, slide 13. It states to add significant figures the exponents must be the same. So in this case, we want to add numbers that are written in scientific notation. In order to do that, the exponents must be the same. These exponents must be the same. In this case, they are the same. So we can just go ahead and add 2.8 plus 3.4, which equals 6.2, and then write times 10 to the third power. So if the exponent parts are the same, we just add like normal, and our answer gets the same, times 10 to the same exponent. Okay. However, let's look at the next problem. It asks to add 2.6 times 10 to the third plus 4.3 times 10 to the fourth. Okay. Now these exponents are not the same. In order to add these values, you need to change the exponents so that they are the same. So make exponents the same. Okay. So let's go ahead and look at this example so I can show you how to do that. Okay. We're starting with 2.6 times 10 to the third plus 4.3 times 10 to the fourth. Okay. Now in this case, it doesn't matter if we make the exponent a 4 or a 3. The point is they just need to be the same. So let's go ahead and change all the exponents to the power of 4. So let's change all the exponents to 4. Okay. So we are going to have to change this value. Okay. So this will become much easier with time, but right now I suggest actually writing out this number. So this will become 1, 2, 3. So this will become 2,600. Okay. In order to write this as a value with a times 10 to the fourth next to it, you're going to have to hop your comma 4 times. 1, 2, 3, 4. So you're going to have to write your value as 0.26 times 10 to the fourth. Okay. Now double check, you can write this out again and make sure that your numbers are the same. And in this case it will be. So 2.6 times 10 to the third is equivalent to, it's the same number as 0.26 times 10 to the fourth. It's just written differently since we want these exponents to be the same. Okay? So our next step would be to write 0.26 times 10 to the fourth. I'll put that in parentheses so it's a little more clear. Plus 4.3 times 10 to the fourth. Alright, so now we just do normal addition of 0.26 plus 4.3. So you get 4.56. And then since our exponents are the same, you just write times 10 to the fourth. These same rules apply with subtraction. So for addition and subtraction, you need to make sure that your exponents are the same. If you look at that example sheet, okay, number 3, we can do a few examples. Let's look at A. It states here that you have 5 times 10 to the negative fifth plus 2 times 10 to the negative fifth. Here our exponents are the same. They're both negative 5. So in this case, we can just add normally. 7 plus 2. I'm sorry, 5 plus 2, which equals 7. Alright, times 10 to the negative fifth. Let's look at the next one. Okay, the only difference with this question over here is that it's involving units. So make sure that when you want to add or subtract, that your units are the same. It's just like algebra. If you want to add x's, you can only add x's. You can't add x's to y's. You can't add apples to pears. You can only add apples. Here we have grams and grams, so we can add these together. Okay. However, in this case, look, our exponents are not the same. This one is -5. This one is -3. So we are going to have to make a change to one of them. Let's go ahead and change -3 to -5. I just randomly picked it. If you want to make both -3, that's fine as well. You'll get the same answer. Okay. So let's look here. I'm going to write this over here so I have some more space. I have 5 times 10 to the -3 grams originally. I want to write that now so that my exponents for this value are -5. If I write out this number, 1, 2, 3, it is 0.005. Okay. In order to write this value with an exponent that is -5, I need to go 1, 2, 3, 4, 5, hop my comma, and then realize that I'll have to write 500 times 10 to the -5th. Okay? 500 times 10 to the -5th. If I rewrite that, 1, 2, 3, 4, 5 will give me again 0.005. Okay? So 500 times 10 to the -5th and 5 times 10 to the -3rd are the same numbers. But in order to add and subtract, we're going to have to use this number, 500 times 10 to the -5th, so that the exponents are the same as the first part of the question. Okay? So here we go for part B. We'll write 7 times 10 to the -5th grams plus 500 times 10 to the -5th grams. Okay, 7 plus 500 equals 507. Since our exponents are the same, we just write times 10 to the -5th. Okay, now I see the video is getting pretty long, so I'm going to stop it right here, and then I'll continue with this worksheet in the next video.